Here we are in Chapter 5, Review Exercises 14 through 24. And as we recall, the general way, the method, the process by which we factor is we first try to pull out a greatest common factor. And once we've done that, we look to see how many terms there are, 2, 3, or 4. If there are 4, we can group. Use grouping. If there are 2, we need a special case where it is either a difference of squares or a sum or difference of cubes. So those are the ways of handling two terms. And then if it's 3 terms, we have a couple of different things to do. First of all, we say, what is the lead coefficient? If it is equal to 1, then the thing looks like x squared plus bx plus c. If it does not equal 1, then it looks like ax squared plus bx plus c. And we have 2 options. Is it a perfect square? So that is a perfect square trinomial, such that it's something squared plus 2ab plus a b squared. So are these 2 perfect squares and then the individuals times together and doubled in the middle? Then it's a perfect square. That will save us doing the AC method on perfect squares where we get really long numbers. So we just check and see if that works. Or we do AC, which means you take A times C, first coefficient times last one, then you split B, and now you have 4 terms, so you will slide right up there and go back to grouping. So that's our general strategy for getting these done. So as we go through these, we'll use each one of those. So number 14, first of all, is there a greatest common factor? That has 2s and 7s, that has 3s and 5s. No, there's nothing there. So we have 1, 2, 3, 4 terms. We use grouping. Get that with a chainsaw right there. Cut that in half. We can now pull out a 2a. And what do we have left? 7. Oh, we can pull out a 2a squared. I apologize. We can pull out the 2 and then an a squared. And we're left with 7a plus 5. What can we pull out of that second half? The plus sign. And out of a 21 and a 15, we can pull a 3. And we're left with 7a plus 5. So we now can pull out this 7a plus 5. And we are left with that 2a squared at the beginning and plus a 3. And then we check and see, can we go any further with either one of these? That one certainly we can't because it's just an a to the power 1, but this one is an a squared. So we might be able to see a difference of squares or difference of cubes, but the 2 and the 3 don't fall into that pattern, so we can't use those. All right, next one. Number 15. Is there a greatest common factor? No, this doesn't have any x's and y's, and that doesn't have any numbers, so there's nothing common on all those. So there's 1, 2, 3, 4 terms, which means we're grouping. Cut that in half and we can pull out a y, and we're left with x minus 6. All right, what can we pull out of the second half? The positive sign and the 3, and what are we left with there? X, 18 divided by 3 is a 6. So we're pulling out that x minus 6, and we're being left with y plus 3. If you notice, I did this problem where the green was on the right-hand side, the one we pulled out, and over here, you'll notice it was out in the front. It doesn't matter which way these 2 factors are written. The commutative property of multiplication ensures that they are always the exact same thing. Number 16. 2x squared plus 7x minus 6. Is there a greatest common factor? We always got to check that first. There's not. How many terms? 1, 2, 3. So this is a trinomial. Now we ask, what is the leading coefficient? It is a 2. So we're right down here. The leading coefficient is not equal to 1. So we check to see if it's a perfect square, see if that'll be easy. Nope. The 2 and the 6 are not perfect squares. So we're going to take a times c. That's a negative 12. And we are going to split the middle. What times is up to negative 12? 1 and 12, 2 and 6, or 3 and a 4. Oh, look, 3 and 4 will add to 7. If that's a plus 3 and a plus 4, that'll add to 7. But wait a second. Positive 3 times positive 4 is not a negative 12. So those are not the ones that work. Are there other ones that might work? A 2 and a... No. None of them work. This guy does not factor, so he is known as prime. Just like prime numbers that don't factor down any smaller, this one will not. It's a prime polynomial. Number 17. 9m squared minus 121. Is there a greatest common factor that we can pull out of those? No, there's not. We now have two terms, so we're looking for a difference of squares or a sum and difference of cubes. You'll recognize 9 and 121. This is 11 squared, and this is 3 squared. So the difference of squares pattern is you take the square root of this guy, that's 3m, and the square root of this one, which is 11, and then one side is a plus and one factor has a minus in it. And those guys are called conjugates, and that's the pattern. Number 18, x squared minus 10x minus 24. Is there a greatest common factor? No, there is not a greatest common factor. So three terms, 1, 2, 3. Leading coefficient is 1. That means it's going to be a nice fast one. We look to see what times up to negative 24. We know it's going to be an x and an x. We got to find these two numbers. Times up to negative 24. So it could be a 1 and a 24, a 2 and a 12, a 3 and an 8, or a 4 and a 6. Now we notice that 4 and 6, if they were both negative, would add up to a negative 10, but negative 4 times negative 6 is a positive 24, so it's not those guys. One has to be negative, one has to be positive to times to a negative, so it looks like a negative 12 and a plus 2. Negative 12 and a plus 2. All right, number 19. Greatest common factor. Let me see. There's an a in all of them. Yeah, there's an a squared in all of them. And there's a b to the fourth in everything. And so we pull that out and we are left with a squared. We pulled out the b to the fourth plus a minus 6. All right, what's left has 1, 2, 3 terms, and the leading coefficient is a 1, which means this guy is going to break down kind of nice and easy with an a there and an a there. And then we need to think what times is to a negative 6 and adds to a positive 1. That could be a 1 and a 6 or a 2 and a 3. Timesing to a negative, that means these are opposite signs, so they really subtract to a plus 1. So it looks like those two right there, a minus 2 and a plus 3. And certainly this guy cannot be forgotten and is just written out there in the front. All righty. Number 20. 64x cubed plus 125. Is there a greatest common factor between 64 and 125? 5 goes into this, and this has 2s and 4s and 8s and 16. Nope, nothing the same. All right, so we have two terms. So we're looking either for a difference of squares or a sum or difference of cubes. Here's the plus sign that says we are at a sum of something. And so this could be written as 8 squared, but it's also 4 cubed. This is 4x all cubed, and this is 5 all cubed. So in our formula, that's the a and the b. So it factors into the pattern, this plus that, 4x plus 5. And the other side, you would have to times this by 4x squared, which is 16x squared. That's 4x altogether squared. Have to times 5 by 5 squared, which is a 25. That's on the end. And then the opposite sign of 4 times 5, 20x, gives us the sum of cubes formula. All right, number 21. X to the fourth minus 81t to the fourth. There is no greatest common factor. There are two terms, and it is a subtraction. So we look to see, is this a difference of cubes or a difference of squares? And yeah, these are squares squared. So if you were to do this guy and find out what the square roots are, you get x squared plus 9t and x squared minus 9t. squared. Oops, forgot those little squareds there. And then we look at this. Can these go down any further? Yeah, this one is a difference of squares. Again, x minus 3t and x plus 3t. And can this one go down? No, only a difference of squares can be factored more. The sum of squares cannot be factored. So that has to stay right like it is, and then that becomes our answer. All right, number 22. 4x to the fifth minus x cubed plus 32x squared minus 8. Is there a greatest common factor among these? No, there's not. So we count, there's 1, 2, 3, 4 terms. So we are in grouping. So we chainsaw that guy and we get, what is this? We can take out an x cubed and we're left with 4x squared minus 1. And then on the second side, if we take out a plus 8, we're left with 4x squared minus 1. So if we take out the 4x squared minus 1, we're left with x cubed plus 8. Now as we look harder, look closer at it, this is a subtraction of two squareds, which means 2x minus 1, 2x plus 1. And this one is really x cubed plus, yep, this is two terms, cubic here, so this is a 2 cubed. If you can identify 8 as a 2 cubed, then we realize we have to break this one apart as well using the sum of cubes. So it'd be x plus 2, and then x squared and a plus 4. And then the magic middle term is a minus 2x, and it causes everything to cancel in the middle. This one broke up into 1, 2, 3, 4 different terms. Wow. All right, number 23. Is there a greatest common factor? Oh, it looks like we have y's everywhere. So we're going to take out a y squared and be left with 2y squared plus 3y minus 35. Okay, what's left has 1, 2, 3 terms. Leading coefficient is not equal to 1, so we're going to have to take 2 times negative 35 is negative 70. Oh, I guess we should have checked to see if this was a perfect square, and now 2 nor 35 are not. Okay, negative 70, that's 1 and 70, 2 and 35, 3, 4, no, 5 and 14, 7 and 10. And that looks like it is times to a negative, meaning one of these has to be opposite. So negative 7 and positive 10 look like the numbers that match up to give us a positive 3. So this is actually 2y squared minus 7y plus 10y minus 35. We now have 1, 2, 3, 4, and you'll see every time you split b like we just did, that means you're going to group. All right, so let's group, and we can pull out a y, and we're left with a 2y minus 7. And then we pull out, what can we pull out of this other part? 5, and we're left with 2y minus 7. So if we pull out that 2y minus 7, and then we're left with that y plus the 5 right there. Good. And then this y squared is still sitting out in front. It just kind of just dropped down there. Excellent. All right, and the final one, number 24. 16m squared minus 56m plus 49. Is there a greatest common factor to those? I don't think so. This guy has 2s and 4s and 8s, and that guy has just 7s and 7s. So nope, no perfect, no greatest common factor there. We count up the number of coefficients, and we have 1, 2, 3. And the leading coefficient is not a 1, so we would take 16 times 49. Over here. Oh, wait a second. Those guys are perfect squares. We need to check to see if this is 4m And square root of 49 is a 7, and that's a minus sign. Let's check to see if this pattern works. Certainly 4m times 4m is there, 7 times 7 is there. What's 4 times 7 times 2? This middle term is what we're checking. 4 times 7 is 28, times 2 is 56. Well, 4 times negative 7 is negative 28, times 2 is negative 56. It is, and we didn't even have to go through that entire big list. Our educated guess worked, and that's what perfect squares are all about. Good.